Next presenter, next speaker is Alberto Amuzzoni, and he is research and development manager at Drillmec in Italy. Alberto is a mechanical engineer, graduated from Polytechnic University of Milan with a master in machine and integrated production systems. He has held many positions within the R&D group at Drillmec, from design engineer, project engineer, operations manager on field applications related to innovative technologies. You probably know Drillmec. It's a big actor when it comes to manufacturing drilling rigs and equipment, mainly for upstream oil and gas. But they also have a long experience with supplying drilling rigs for actually 45 drilling rigs for the geothermal applications. I've actually been working closely with Drillmec in my previous work life and had the opportunity to visit their impressive plant several times, which is close to Piacenza, which is in the northern Italy between Milano and Parma. And it's a really nice area and very nice people, always a lot of good food and good wine. So I look forward to being invited again. So, but I also have a fun fact on Alberto, of course. He's a golfer, but he's modest, and he says that he's struggling to become a good golfer. Yeah. But I think he's modest. But I know I've tried golf. I'm not a golfer, but I know that the ball is small and the holes are also small. And since you're in the drilling business, maybe we should just agree to make the holes a little bit bigger. Yes, I know. Yes. So, but you also love bicycling, and you look in good shape. So I guess you're a good bicycle. Thank you. Yeah. Okay, so I look forward to hearing about your developments and what's going on at the Drillmec.
Okay, thank you very much. Yes, the only thing that I understood about golf is that I'm not becoming a golfer. So, but luckily I have another job as in Drillmec. So the future is here, not in the for the golf. Okay, so Drillmec is a Drillmec manufacturer. We provide a complete range of drilling equipments, from the single equipments up to the complete drilling package. Christian already said that we have a good experience in the geothermal field. We started 20 years ago working for this field, first in Italy because we had good development of the geothermal in Italy, in Tuscany. I think that you know that area. But then we extend our business all around the world, and as you can see now, we have 45 rigs working for the geothermal field. The typology of rigs we can provide are many. The portfolio covers a wide range of applications, starting with low-end POS, where the truck-mounted rigs are suggested. For the medium-end POS, we can provide mobile rigs, mechanical rigs basically, named MR series, but also our main product for the geothermal, so the HH series. This is the type of rig most employed for the geothermal. And then we will see the reasons. And then looking at the deep wells, we can provide the conventional land rigs up to 3,000 HP of power. But we have also a new series that is named HIAD. Then we will see the features for this rig. Looking at the geothermal drilling, we already So this very interesting presentation regarding drilling in general, and also the geothermal drilling is facing many challenges, very similar to the oil and gas drilling. So if you look at the challenges, first, we often have to drill wells in remote sites, and we have to also have a limited footprint for the rigs. So the solution for Drillmec is to deliver drilling rigs characterized by a fast-moving solution, and also very compact, so to reduce the footprint of our rigs. Then looking to the wells project, let's say, in general, the geothermal wells are characterized by high deviation, extended reach. Many of them are multilateral wells, and also, of course, we have high temperature at the bottom, and possibly also high pressure. So regarding this, Drillmec developed a new technology that is named HUD, heart of drilling. So this is the commercial name, but it's a continuous circulation system to maintain the mud circulation always active during drilling. Then we will see the features. Then last part of the challenges, we need to drill many wells in a short time to develop the fields, and of course keep the the safety standards, because the most deeper we go, the most safety is always, a goal for the drilling. In this case, for this reason, we develop only high-level rig automation. Okay, so the main topics of the presentation up to first is that we would like to present our HH series, so a typology of rigs that is largely employed for the geothermal, and then the continuous circulation system. Starting from the HH series, you can see one typical picture of the one HH rig on the right part of the slide. This rig is characterized by fast moving. You can see that the mast is telescopic, it's not a conventional mast. So we are not using drawers in order to put the pipe into the well. And this is an hydraulic mast, telescopic. Okay, so the top drive is put up and down with this kind of antenna mast. And okay, all the rig is studied in order to be moved in a fast way. So if you look to a conventional rig and to a HH rig comparable, of course, the number of loads for the HH rig is 50% compared to the conventional rig. The footprint is highly reduced compared to a conventional one. And in general, this small footprint and this compact design is also helping with the mission in order to build up the rig now, because we have less manufacturing process, so it's faster, the manufacturing process, and also if we look at the moving, we reduce emission because we have less moving operations to move the rig. The main feature is the advanced automation. This rig was born as a typology we're talking about 25 years ago, first HH rig in Drillmec, and was already automated. So the aim from the beginning was to avoid people on the floor during drilling operation, dripping also, of course. So there are many handling systems into the rig in order to avoid people during the pipe handling operations on the rig floor. And everything is controlled by the driller from the driller cabin. This is a typical example of how we can move an HH rig. We are in Tuscany here. And okay, it was not easy to move this kind of mast on those roads, as you can see, but we started this kind of trailer with 8 steering axes in order to move, was especially designed for our customer in this case. Okay. That's interesting. Okay, as you can see, the footprint is okay, we have a comparison here between the conventional footprint and the hydraulic, the HHCL footprint, and is 50% in terms of area compared to the conventional rig. Also, another important feature is that the visual impact of the rig compared to a conventional one is highly reduced, because also the mast is low compared to the conventional one. And that's why this kind of rig is also employed often in the urban areas. Also the noise is another important advantage. It's reduced compared to the conventional rigs. Okay, now I would like to show you this video. I didn't remember the music, sorry, but it's good. Okay, but so now we are looking at a typical tripping operation that is 100% automated on the HH3. So we have the rack for the pipes with a central handler that is putting the pipes into the mouse hole, and then the top drive is tilting in order to pick up the stand from the mouse hole. This is okay, the rig can perform this in trip in and trip out from the well. So this is helping a lot to reduce also the risk on the rig floor, because we don't have people working in that dangerous area. And this was from the beginning. I mean, so we studied this kind of rigs like 20 years ago. The rig is fantastic, so that you can see people, but usually there is no people in the drilling. No, it's important. Now we switch to the second topic of the presentation, that is regarding the conventional, this continuous circulation drilling. So first, okay, as you know, most of you, I think, the conventional drilling is based on connections on the rig floor. So every time we need to add a pipe to the drill string, we need to pick up the pipe from the rack, and then you need to stop the circulation of the drilling fluid, in general drilling mud, in order to add the new pipe to the drill string. And this can give many problems to the drilling operations. And that's the reason why usually we see the people in the videos on the rig floor always trying to make the connection faster and faster, and this is not safe. Okay, but the reason is that they are struggling with the well in that moment, because there is a risk to stop the circulation of the mud during drilling, because you risk to overcome the two lines that are characterizing every well, so the pore and the fracture pressures. Okay, so every time we stop the circulation, we create this discontinuity, not on the surface, but into the well. And potentially this can also create a negative surge during when we stop the pump, that is overcoming the mud weight That if, of course, I'm talking about overbalance drilling. So this negative surge can potentially give also a kick. And this is something that must be avoided, of course. When we restart the circulation, we have the opposite effect to the formation. So we have a positive peak that is affecting the formation at the bottom. And this can create fractures or the famous ballooning effect. No? That is then is something that must be managed during the drilling operation easy. So in general, what we want during drilling is to maintain the line is translated. Sorry, but the black line was in the middle between the two, the pore and the fracture. So the aim would be to maintain this line in the middle, always active, without any interruption of the circulation. This is the ideal situation during drilling. To do that, Drillmec developed this system that is named HOD, Continuous Circulation System. Is a system that is based on the use of subs. So these subs must be pre-mounted on the top of each stand into the rack. Okay, so you need to prepare one drilling phase, pre-mounting these subs, special subs, on the top of each stand, ready to drill the phase. The concept is when you drill the stand and you reach the rig floor with the top drive, so you finish to drill one stand, you must theoretically interrupt the circulation to pick up another stand, okay, from the rack. With this system, you can avoid this, because with the sub pre-mounted on the top of each stand, you switch the circulation from the top drive to another line. So we put a connector that is named clamp on the side port of the sub, and then we switch the circulation from the top drive to the side port. And then we can disconnect the top drive and pick up another stand, but the circulation of the mud is active into the well. When we have the new stand on the top of the drill string, we can re-switch the circulation again to the top drive and disconnect the clamp. So it's like a sort of pit stop, we say, no? That is happening on the rig floor. To do that, to do this switching, we use a manifold that is connected to the standpipe manifold of the rig. So we need to basically cut one line of the mud and put this manifold in it in order to control the switching operation, because we have a sequence of opening and closing with the valves into this manifold. Everything is controlled by a control system, PLC control system from the driller cabin. So which are the benefits of this kind of system? Okay, we can maintain, of course, the circulation means to reduce the likelihood of kick during the connection. And for the geothermal is important because we maintain the circulation, so we can also cool down the downhole equipment. So we avoid this kind of thermal exchange with that is happening when we stop the circulation at the bottom. And we improve the quality of the hole because we maintain, thanks to the active circulation, we maintain the bore stability. We avoid all these problems linked to this discontinuity that is happening during the connection. And okay, we maintain also another important feature for the geothermal, the cutting transport, because we saw already that the wells are high deviated. So when we stop the pumps, the cuttings are giving these cutting beds on the drill string, and this can lead to slap pipe events. And in general, this, of course, is increasing the performances, drilling performances, thanks to these reduced MPTs events. performance improved, the cost reduction is something that is going together. We have this link. Okay, so we saw these two technologies, and this is the match between the HH series and the continuous circulation system. So this rig is named AED. Is an acronym. I don't remember the name, but anyway, is a match between the HH series and the conventional rig. So we can manage stands of tripod stands. So exactly the same compared to the conventional rig. And we have, in this case, a offline system that is providing a complete pipe handling offline. So we can prepare the stands even during drilling. Okay, so we can manage all these operations with the pipes during the drilling operation. So we save time. We also include the continuous circulation system as a part of the rig. So we have an handler that is moving the clamp to the sub during the connection. And so the continuous circulation system, in this case, is a part, one equipment like the others that we have on the rig. So this is our idea that can regarding the best solution also for the geothermal field for the future. That's it. It's
Yes. Yeah. Thank you, Alberto. Questions?
This circulation setup here.
It's funny.
Is that if we join?
Yes. Yes, you must put one sub on each stand that you need to use during the drilling phase. If you want to drill with the continuous circulation. So the phase that you studied before, you need to study the well project, of course. When the continuous circulation, theoretically, you can use it during every drilling phase. But if you want to maintain the circulation, one sub on the top of each stand, and you put it into the rack, ready for the drilling phase.
You have a picture of it?
Picture of what?
Sub?
Yes, many pictures.
You didn't see it?
No, yes, it's here.
So it's each 3 pipes, right? One stand is 3 pipes.
Yes,
One side.
yes, correct. Yes, usually it's 3. In offshore could be also 4.
But where do you connect here? See that?
Okay, this is a connection on the rig floor with the continuous circulation. Now, the sub is connected to the clamp, and we are circulating from the clamp now.
Okay, I see. But there's a hole there then.
A hole is on the side of the sub because we need to pass with the mud but consider that the clamp is automated now. Is the automated device and is open in one side port. Okay, on the side part of the sub in an automated way, basically a cap. Okay, but you cannot see it because it's inside. No, because it's inside. No, yeah, from outside you can see it. But anyway, inside is opening a cap, and then the circulation is switched. Then inside the sub we have one system of valves that is closing one side, top drive in this case, and is opening the side port. Okay. And but the cap that the clamp is opening is acts like a second barrier. So we have cap, valve, and then the hole, the drill string hole. Yeah.
Take the other picture you had showed it starts side port. This one.
That one. Yeah, the side port is yeah, you can see it is not clear here, but there is a side port on each sub. Yeah. This one.
How does it affect the tripping time?
This one?
Yeah.
Also is very affecting the tripping time because you know when you need to put the drill pipes and also take them out from the well, not and it's a risk because you risk to, if you're too fast, you risk to also to create some problem with the kick or something like that from the bottom, no? So in general, this system is very simple as a concept, but is helping on many aspects from the drilling of a well. Yeah, and yeah, it's a simple concept. Then it's not so easy to create this set and to make it worse. And because you know it's always we are acting with something with high pressure, no. So it's this is what is the main. But we look at from the beginning to the safety of the system. That must be the first feature of it. Yeah.
Yes, Gilbert Renders. What is the adoption of this continuous circulation system right now in your operations in geothermal? Because as you said, since it affects the temperature of the well,
Yeah.
I guess this is very important, particularly in Italy, where you have high enthalpy wells.
That's a very good question. You know, is not so not as we want, and because first we have a very good feedback from the oil and gas, because and especially in offshore operations where the costs are very high. So companies start to understand the importance of this kind of technologies, no, in order to prevent any accident or events, negative events on the rigs. For the geothermal experience, we need to reduce this gap, know-how gap. No, so I think the problems are the same or very similar, but I think that there is not so. This is sometimes is like a cost. It's not a cost. It's helping to reduce cost. This kind of system. So we need to close that gap and work on that. Apart from that, in Italy, we had an experience with the energy company in Italy, in Tuscany. So they tried this system. It works fine with the well, but again, there is this barrier, no, that they want to, you know, in general, also in the oil and gas, it's like this. There is the sort of resistance looking at new technologies. It's like this. It's the geothermal is even worse because they need to close the gap also with the oil and gas, so there is more resistance. But I think it's just a matter of time. Just a matter of time because the problems are very similar sometimes between geothermal and oil and gas.
And above 200 degrees Celsius, I guess, it
No.
would be very difficult to drill a well with all the electronics.
Yes,
absolutely.
Yes, the more technology you use at the bottom, the more the system is helping. Because you know, the circulation is one of the aim is also that one, to maintain the equipment in a good condition with the temperature. Yeah.
Yeah, I don't know. It depends on the answer.
Sorry, I'm going. Yes.
No, I was just curious because you mentioned obviously you have these challenges downhole
Yeah.
with regards to tripping and so on. So, how do you take that into consideration? Is it part of your system or is it more a manual part that monitoring of what is happening downhole?
Okay, and it's not part of our system, even if we are working also on the monitoring of the especially on the mud monitoring conditions, like some parameters coming from the well. But for sure is helping who is monitoring, not us, but in general the service company that are providing this kind of logging or something that is coming from the well. Because the circulation is also keeping the active the link to the bottom. So you receive the information in a continuous way from the bottom. So that's this another advantage. Yeah.
Okay, thank you very much, Alberto.
Thank you.